Here's what I think about related rate. A lot of you guys are struggling. I understand completely. You have to believe in yourself. You have to be able to take one step at a time. You're not supposed to jump 20 steps. You're not supposed to solve the problem right away. So it's like you climbing a mountain, right? You're climbing a mountain, you cannot see how much you don't understand. You're gonna see, just focus on the next steps. You cannot be like, oh yeah, that's a Mount Everest. Oh no, that's too high. I cannot make it, and I'm done. Yeah, and yeah, that just you'll never get there, right? You'll never get there if you look at that perspective. So what I want you to do is not just look at it one step at a time. Don't look at how high up or how high you are or how high you need to go more. You just take that one steps I need you to take. If you start focusing on that stuff, stop focusing on the unknown part, then you will do well. Okay, you will do well. So this is our first question, which is this classical cone problem. And what we're gonna do is we're gonna draw a cone. Yes, conical means a cone. So I'm gonna draw it out. I'm gonna draw it on the red cone. Exactly. Who cares? Okay, so I have a comb here.
It's a pretty good color.
Yeah. Fact.
That's no opinion. Well, you can't say that. Okay, it's too stuffy.
Okay, so I have a 16. So this is a 16 feet, and this is a 4 meter. Sorry, meter. 4 meter and 16 meter. And I'm gonna draw a water here. And this water is gonna be something like
12.
Like from here to here is 12. Okay, but inside it's a 16 feet high. So from here to here is a 16. So from here to here is 16. Okay, so what we're gonna do is we're gonna pay attention to this. So let's extract one information at a time. You're not supposed to try to accomplish the whole thing by yourself. You're supposed to just look at what you know, what the number to give it to you, and just go with that. So let's start with something that's a first, which is you have a 2 meter cube per second. And so what would be 2 meter cube per second in terms of calculus? dB over dt? Why do you think it's dB over dt as opposed to dH dt or dr dt?
I think it's dt because of the cube.
Jake, shh. It's got a cube. So the units usually give you a lot of big information. So I usually, like, students have a hard time with like, is that dr dt or dH dt or dV dt? Well, look at the units. If it's a one-dimensional, it could be r or it could be the height. But if it's three-dimensional, then that has to be a volume. Now, with that being said, with dV dt that we know, now what do we want to find, which is how fast does the water fall? Now, what's wrong with dV dt? There's something wrong with it.
It's not true.
It is not true, but what's wrong with it? Why?
The water level is falling.
It's draining. So the key word is this is the negative, right? So that you have to worry about that's a negative sign. That's the one thing that I always tell students, pay attention to the sign. Because sometimes the multiple choice, you can judge, you even know clue, right? It's draining. Guess what? My dH dt has to be negative. Right? So those are the things that you want to think about, and you can think about what's the correct choices. Now, with that being said, we want to looking for what? What are we looking for? Yeah, but what does that mean in terms of calculus? dH dt, good. And do we have a condition? H equal to 12. So I draw a straight line with the h equal to 12, and that's equal to unknown. And then when we do that, we say, okay, we are almost there. We're gonna get there. We're gonna get to a very, very um what's the relationship?
It's h pi r squared over 3.
Yeah, 1/3 pi r squared h. Yeah, that's right. I just do a different order. Good. Good.
Yeah. I'd say that's pretty good.
That's pretty good. Okay. So here's a problem that you are gonna foresee yourself doing, and that so this is always that you got to think about before you're doing something. Like you think before you do. This is always a good process. Now, if I were to do derivative respect to time, what if what is a problem that you will foresee yourself get into?
Messing up the derivative.
Andrew?
I wouldn't know what to do with R and H. Like,
You have
I think I would
TRDT,
do
right?
both.
You don't know
You would do,
TRDT.
So yeah, you don't know what to do with this r squared h, and the reason why is you can actually take the respect to time here, but the problem is you're gonna get a product rule. So that means you have to know what a drdt or dhdt. You have a dhdt is unknown, but we don't have a drdt to work with, so it's become a fruitless derivative. Okay, so you're not going to get any result because you don't have drdt, because not a whole question give you drdt. So that means there's got to be a second relationship here. So what is second relationship? That's the part that kind of make a Cohn problem. Is no,
the area of a triangle.
no,
Volume of a triangle.
no, volume. No.
That's what we're already doing, though.
A volume of a triangle.
We don't know anything other than the shape.
Can I say that you're a dumbass in a live stream?
We know the
I already
volume of a sphere.
No, I'm just kidding.
You might get
If we know
demonetized.
I know. It'll be canceled the next day. I'll get fired. No, you are a smart ass. Okay, so anyway, what's the second relationship that you think it's gonna be?
Volume of a sphere.
There was no sphere.
Circle is area of the circle.
No.
Mr. Ye, I can't read the question right, but are you surface area of a cone?
No.
No, that's the one thing that we say, who cares?
Sure. Do you know the
Yes. No, there's no cylinder here, there's a cone.
It's a third of a cylinder.
Give us a hint.
We need an area of
Tilt your head 90 degree.
Triangle. Area of a triangle. Perimeter of a triangle.
That doesn't mean zero. Oval.
Almost. It's getting closer, getting warmer.
Triangle, we can use the side, the length as the side.
Height.
and use like dx over
If you turn your head sideways, you shall see two triangles.
Right.
What are the relationship of those two triangles called?
They're similar.
Thank you. Good job, Andrew.
Okay.
So there was a two triangle. Yes, there are two triangle here. And that triangle is called a similar triangle. So a similar triangle is within the cone. And we are going to focus on similar triangle today because what the shadow problem has a similar triangle as well. And they were in different orientation. But a similar triangle is good. So what's one thing that doesn't change in the cone? The cone has, the water is changing, right? But the thing is the cone never change. Cone stay the same. They have the same what? They have the same radius and the height, right? There's something that does not change, right? So with that, you're going to have a relationship. You got a R over H. Why is R over H? Well, you got this triangle, R and H. Guess what? You can find out, if you have a radius at any given moment, you can find out how high it is. If you have a height, then you can find out a radius because that relationship. And that has a ratio. This ratio is the radius over the height. which is 16. And with that ratio, then you can simplify it.
1/4.
And then you can change. You can say that's equal to 4r equal to 1h. But the problem is I don't want to solve for h. Why? Because I want to plug it back in here. If I do that, then I'm going to get r to the cube. But we don't have a dr dt. So what are we doing that for? Nothing. So what we're going to do is, instead of solving for r, instead of solving for h, we're solving for r. So r is equal to h over 4. And then that is the way to reduce the variables. Why? Because you plug it back in this in here, what would I get? You will get volume. You will get volume. Okay, you will get volume. Oops, my bad. I don't know what's happening.
Oh my goodness.
Volume is equal to 1/3 pi r squared h. Now I'm gonna substitute the r. Okay, so it'll be 1/3 pi r, so it'll be h over 4 square h. That's equal to 1. That's equal to pi over 3rd. This one's h to the 3rd. Why h to the 3rd?
Because you had to square h and then you
And then it's 16, right? Because 4 had a square too. So that's equal to pi h to the 3rd over 48 a volume.
Okay, that's so poggers.
Now why that's important? Because that is the way you reduce a 2 variable down to 1 using the second relationship. Now I'm going to take a derivative respect to Tom here.
Would you do quotient rule here?
Nope, you will not. If you do quotient rule, I will
smack you.
There's a single number below. Why?
constant multiple rule. Thank you. So you take it down to 3, just do a power rule. Just take it a pi over 48. And just take it here and just take h to the 3, which is 3h squared, and then dh dt. So that's equal to 1 over 16 pi h squared dh dt. Now I'm going to plug in the dv dt, which is -2 in this case, is equal to 1 over 16 pi. H is what? Well, we don't know. It's 12 squared dh dt, because that's the condition. And -2 equal to 1 over 16 pi times 144 dh dt.
Is that
1.4 divided by 16 is going to be like 9.
9, good job.
Dude, I'm so smart.
9, so it'll be 9 pi dh dt. And then -2, so dh dt, guess what? -2 over 9 pi.
You got me messed up.
That's smart.
it's kind of sus. Not
This is on a short day.
Yeah, you got me messed up if I'm doing this on a short day.
You got me messed up if you're doing this on a long day.
True. You got me messed up if I'm doing this at all.
Yeah, why?
All right, so so what happened is this is one question that you will have this Costco problem. If you do a couple times, you'll get done in like 2 minutes. So that means you got extra questions.
They beat the Dolphins.
No, because I'm happy. I'm happy.
You're happy, so I can give you extra questions.
We're both 1-5 now.
All right, so what we're gonna do is we're gonna talk about does everybody don't understand this question? Raise your hand and let me know where the question is, and I can tell you what is that you don't understand. Yes, Luca.
Kind of basic, but what's the difference between dv, dr, and dt?
dv dt, dr dt, dh dt. So dh dt is how fast the water is rising or going down.
Okay.
And then DRDT is how fast the radius is expanding. So if I pour water in, the radius is gonna increasing, right?
Okay.
So how fast the increasing the radius is. But really relevant to the height, because the more higher you get, the slower than DRDT is.
Okay.
Does that make sense?
Yeah, I see what you're saying.
And then also when it go down, DRDT is gonna become negative, bigger, faster. Because if you drink the water, it's gonna drink much faster when it goes on the bottom. Now dVdt is how much volume is changing per minute. So how much the water is leaking out or how much water is pumping in. Okay. Any other question besides this one? So we're gonna talk about this classical problem today. And I want you to read this question like 20 times. I don't know.
Oh my goodness.
AJ, you have good eyes. I cannot see from this far. Like I can, but
Mr. Ye,
I have
Mr. Carmody,
and reading.
Mr. Carmody, what?
he would like love this question. You remember that?
Oh, yeah. I'm good thing Mr. Carmody's gone. That question now. I don't know. Mr. Carmody.
Oh man, 6 feet tall. That's me. I'm 6 feet tall, Mr. Ye. Not trying to brag or anything. I'm 6 feet tall.
Yeah, I mean, guess
He
what?
wants me to figure.
Yeah, I'm actually 6 feet tall.
You are?
There's a problem related to me.
Are we about to do the game of the
Related.
raid?
I'm not
Six.
real life.
So
Oh, you have to make a shadow.
And that's a fact.
And
okay, so I want somebody to record what's going on.
I want to record. Take me.
Six feet tall.
Can I be the guy making the shadow?
I'm 6 feet tall.
I need a strong iPhone with the highest flashlight power.
Me.
When you're standing in right now.
Oh wait, this is not very bright. I
Yeah,
think
no, tripod is it for a reason.
No, you're gonna have to. I'm gonna go. I need a strong enough power. Which one has a stronger power? That one's pretty strong.
I'm pretty strong.
Oh,
you're
yo,
strong.
AJ, big AJ, look at his. Oh my.
Okay, so come on here.
Okay.
Stay away. Go away. Sorry, AJ.
No, no, like,
I want to cut it brighter though.
Yeah, you're more like AJ.
I'm 6 foot tall, Mr. Ye.
Okay, so come here. Come here. Sit down here. Okay, so basically, lift up a lot this height. Okay, so if you see the, yeah, that's probably gonna be like this.
You want a piece of paper so you can see the shadow?
You can point it down where it's like.
I need multiple piece paper.
Start whipping up pieces of paper.
I don't know what that was.
Inside my fridge.
Go.
There
You got Mr. Ye.
Probably better angle by the
Okay, so basically, what?
It's because you gotta line up the actual light with the pen.
So no.
He wants the line to be straight. That's it. Keep it there.
So you see the shadow is growing, right? As I'm going away, the shadow is growing longer and longer. And then that is the shadow. Now, if I'm going here, it's gonna go faster, right? If I'm going back, it's shrinking, right? So that's the idea. So a lot of times that you have to think about how fast the man is walking, right? Now let's go back to the question. So we're gonna go back and read the question. So I need you to zoom into that question again.
A man 6 feet tall walks at a rate of 5 feet per second away from a light that is 15 feet above the ground. When he is 10 feet from the base of the light, at what rate is the tip of the shadow moving?
Okay, now let's look at question B.
When he is 10 feet from the base of the light, at what rate is the length of the shadow changing?
Okay, so now my first question is gonna ask you, is A and B are the same answer or are they different?
Yeah.
If we are the answer the same, can you tell me why? If it's different, can you tell me how are they different and why they are different? So let's think about answer A and think about answer B here first, and let's look at this. So we got obviously we got he is 10 feet from the base of the light, and what rate is the shadow moving? And when he's 10 feet from the base of the light, what the rate of length of shadows changing? Are they the same?
Yeah.
Or are they the different?
No, they're the same. I think they're the same. Because like change is defined by like where you're
Okay, so we can
and where the end is.
Harmon, you can point that at the speaker so we can record what it's saying.
Okay, so change, if you're like thinking about it analytically, right? If the tip starts here and ends here, change is just this distance. And if we're measuring the tip moving, it would also just be starting here and wherever it ends.
Okay, so that's Andrew's opinion. Does anybody have different opinion?
Oh, here, let me read it real quick. At what rate is the tip moving?
Okay, Shelia, you want to record Shelia?
Shit.
Shelia?
I think they're different because it says that what rate is the tip of the shadow moving, so like he's moving with it, so it'd be like moving with him. But then when it's the length of the shadow changing, it doesn't matter like how fast he walks, it just gets longer and longer.
Yeah, I
so
think it gets longer.
it doesn't really, it's not really the same thing. It can't really be the same thing.
Okay. Anybody else on team Andrew? So let's take a vote. Who's gonna be on the team then to raise your hand? You have to pick one side. You have to say one side that they are the same answer, so raise your hand.
Can I voice my opinion?
Sure.
That they're
What's your
different.
opinion?
Because one isn't the other. You know what I'm saying? Like length isn't the
Yeah, but it's not asking for the length, it's asking for the change in length.
Yeah, but that's stupid.
I feel like one's asking for basically how big the shadow is, and the other one's asking how fast the shadow
It's
is.
not asking
No,
for
it's
the
how-
length,
how-
it's asking
how
for the
big it's
change
changing.
in
You
length.
can record outside too. So we record whatever's speaking.
Yeah, but
I think no one agrees with me, but it's fine.
and ends there.
Andrew, you know what? I
Also,
agree.
they wouldn't have two different questions.
All right. So
Your tip never changes.
okay. Okay. So let's take a vote.
But your
Those of you guys agree with Andrew, they are the same, raise your hand.
Just because I don't want Andrew to be alone, I got you, Andrew.
Thanks, AJ.
Okay, so those of you guys think, you have to pick an answer. Are you guys gonna pick,
Yeah,
no, is everybody else gonna pick their answer?
I'm picking B.
You're picking B, so who's gonna pick B? Raise your hand.
everyone.
Okay, that's good. So all you guys make a decision, right? So we're gonna discover whether they are real or they are the same or different. So you guys gotta think about the situation. So what we're gonna do is I'm gonna work out the problem, and I'm gonna work out on this side. So so this part is actually I'll work out over there. So
Like right here?
okay, so I'm gonna work out here. I'm gonna draw the picture. So what I'm gonna do is I'm gonna draw a picture here. So this picture is gonna be right here. This is the lamp. That was not straight, sorry. And then this is gonna be some type of big head person.
I'm a big head person.
I got a very big head, guys.
With a small brain, maybe? All right, so I have this man is 6 feet. This is Will with a big head,
It's all
and 15. I think this is 15, right?
15 years old, yes.
15 feet.
You're not 15, are you?
Okay, so it's gonna cast a shadow. This is gonna cast a shadow. So what I'm gonna do is I'm gonna look at this situation. I'm gonna say this is a 15 feet, 6 feet cast a shadow, and this is 10 feet away. So I'm gonna assign some type of variable. I'm gonna assign the distance, some distance here. So the way I'm gonna assign is I'm gonna assign this is x and this is a y. Is that okay?
Sure.
Okay, so that's my question. So it's a 5 feet per second. Is that a dx dt or dy dt?
Wait, what's 5 feet per second?
I don't know. It's a 5 feet with is according to the story, they're walking away from the light.
It's a positive dx.
So that's the movement of the
y x on each thing.
It's dx dt. dy dt is
The
just shadow.
XDT is
Yeah,
5 feet.
No, the D, y is gonna be constant. The light isn't moving up or down.
Yeah.
dx dt is going to be constant.
It's obviously DXDT, right?
Okay, who says dy dt? Raise your hand. Nobody. Everybody agrees dx dt.
dx dt.
Okay, good luck. You guys did well. dx dt is good. So dx dt is good. So now, what kind of relationship I'll be setting?
Pythagorean.
No, similar. Good. You're gonna have this triangle versus this triangle, right? So, can you set up the relationship for me? Anyone? Just one person? Raise your hand if you know it.
Wait, you said Pythagorean. That's
6 squared plus y squared equals.
Harmon?
Y over 6.
X over 15 over y over 6. Almost. Not right, but almost correct. Luca?
X over 16, y over 5.
X over 16. No,
Or
there's no.
15.
15 over y over 5. No. Maria?
X plus y over 15 and then y over 16, I mean over 6.
Good. So 15, I will do it 15 over x plus y. Does that make sense? Because that's this triangle. So it'd be 15 over x plus y. And the other one is going to be what?
5 over y.
6 over y.
Oh, 6. I just can't read.
So now I'm going to do is something called cross multiply. That's going to be 15y is equal to 6x plus y, right?
maybe 6x plus 6y?
Yeah.
Oh, my bad.
15y equal to 6x plus 6y. And then I'm going to subtract it over. So that is going to be 9y equal to 6x. Now that's going to be 9 dy dt is equal to 6 dx dt. We already know dx dt is what? 5? 9 dy dt. So dy dt is equal to 30 over 9, which is 10 over 3 feet. I think feet per
Second.
per second. Now, here's my question now. Now, remember, respect other people. If you want to say the answer, raise your hand. Don't shout it. Because I wanted you guys all thinking. Is 10 over 3 answer for A or answer for B? So, raise your hand if you think. Is the 10 over 3 is the answer for A or answer for B? Look up.
It's, I want to say it's the answer for B.
The answer for B,
The answer for both.
That's what I'm saying.
and yeah, there's also answer for both.
Why would they give us 2? I don't even know.
Yeah, calculus is bad.
And then I
Okay,
think
so
that's not the way Andrew.
Next person want to talk, Richard. Sheila?
I don't really know if this is right, but it says what rate is the tip of his shadow moving? And then since he's moving with his shadow, wouldn't it be moving the same amount? Like same
No,
rate?
because the light's staying in the same place.
Okay, no, that's fine. That's her opinion. That's fine.
I don't
AJ?
Yeah, I think it's gonna be the tip of the shadow because if he's moving, it's gonna be. Well, it'd be negative actually because if he's. Wait, oh no, I'm confusing myself now. Let me think. Somebody else talk.
Caleb?
I think it's A. Like when you move the thingy, the shadow got bigger. like gets expanded.
So you think 10 over 9 is A? 10 over 3, sorry. 10 over 3 for a second. We got for dy dt? Okay. Huh?
I would say it's A since like what I think what A was talking about, it was like talking about both like how he like fast he's moving and like the movement of his shadow, and then like X is like how fast he's moving, and Y is like how fast his shadow is moving. So I would say it's A.
You want to say it's A? Anybody else? Oh, Joshua was speaking. Zoom in on him.
Would be B because Y is the length of its shadow, so dy over dt would be its rate of change, and then A would be his rate of change plus the shadow's rate of change. So it would be dx over dt plus dy over dt, I think.
Raise it or you see it?
Okay.
Oh,
Okay. Okay.
Andrew, it's both, am I right?
yeah.
Okay. How about Marion? What does Marion think?
I think it's B because I just thought like if you're finding dy over dt, then you're finding like the rate of change of the shadow in total. So like that'd be like behind it, and if he's moving, then like.
Let me call on somebody else. Emily, what do you think?
I think I feel like it's B because I don't know. I would say B.
You think it's B? That's your gut instinct. The woman's instinct. I respect that. Sephora, what do you think?
I think it's B because dy over dt would be like the change in the rate of how much y is. And if you look at the diagram, y would be a shadow because the length like coming from this way, so it'd be like a shadow.
Jake?
You want me to be honest, I don't really know, but I'm gonna take the best guess and say it's B. Because like on the image is y is where like the shadow would be, and dy dt is 10 over 3, so I just assume that like as he's moving that would get that would increase like the rate. I don't really know, but that's my best guess. Stab in the dark.
Okay, Asim?
I'm gonna say B because if it was measuring the rate change of the hypotenuse, it would be A because you're measuring both endpoints, the tips. But in this case, you're only for dy over dt, so that means it's B, I guess.
Okay, Will and then Anthony.
He's walking away from the light, right?
Yeah.
So, like, I think that like I don't know, if he's walking away, then it has to be B, right? 'Cause, like if he's walking away, then it's just gonna increase. Like I don't really know how to explain it. I just think that, like that's just what I think. Like about when I make the picture in my head.
No, but what I think,
Okay, okay.
since like he's walking away from like the tip is gonna be constantly moving at 10 feet, like it's gonna be like at that point it's gonna be moving. Like this is gonna be moving. This isn't gonna be like growing because then that'd be like that.
So you think it's A or B?
A. I think it's A.
You still think it's A? Okay, you're not changing? Okay, that's good. I respect that. Don't change.
I could do a little drawing while
Everyone's
I
saying
can't draw
B,
it there.
so.
I showed it to Luca. and I
So
think
what do
I-
you think is, Andrew?
So if I could draw it, I would draw like I'd scoot the man to the right some, draw another triangle, and then you would like be able to see visually like the two tips. You can see the difference. It's gonna be that
So you think it's A or B? Or both?
both.
You think still stick with both?
I'm sticking with both.
Okay. All right.
Uh,
All right. So here's
What's the answer?
I cannot tell you the answer, but
You gotta run this like eventually.
No. I will tell you the answer eventually, yes, but I want you to think about it. Page first period, she gave a entirely different argument. She says, hypothetically, let's assume this is S. Okay, let's assume that A, which is tip of shadow, is equal to 10 over 3. Let's assume that. And she says, how fast the dx dt, so dx dt is 5. Then she said, if I would assume that, what kind of problem am I gonna foresee? No, what kind of problem are you gonna foresee? Yes, Joshua.
The guy is moving faster than his shadow, or like the tip of the shadow.
Not the shadows.
Well, like if the tip of the shadow is moving at 10/3 and the guy is still moving at 5, then he's gonna catch up to it, and that doesn't make sense.
That becomes pretty weird, right?
It's broken.
It's broken.
That would imply that. the
Well, if you
lights are
run
right
faster,
there.
if you can catch up to it.
Like
Like,
you flash. You're flash. It's possible. I mean, this is a good situation. That's a good thing for thinking. She's thinking about what if the A is this, and she said that doesn't make sense. Then her logic says it says B.
JC, you say go run, but
Her logic is B is 10/3. Does that make sense to you guys or no?
That makes sense to me.
Absolutely not.
But then I don't know what A's asking.
it just sounds too like.
Right. What is A?
Like, there's no need to be thinking that early in the morning. That's 7 in the morning.
All right, so that's a good thing to think about. So you guys are the good thing is this. I'm gonna go ahead and evaluate it. I'm gonna go ahead and evaluate this, and I'm gonna tell you what happened. So what she's saying, if this man is walking at 5 feet, so then this be 10/3 subtract 5, you end up being negative. It doesn't make sense. The shadow is growing slower than the man. So that's what she's thinking, which is she thinking correctly, which is she's thinking about hypothetically, if this is the answer, what would it result? And if this is the answer, what will be the result? So she's thinking about those two-layer situation. And those of you guys are gonna develop that critical thinking skill. It's not because of anything else. It's I don't really care about. You guys are discussing what is the right result. It's not the problem. Is not who's right or who's wrong in this case. I want you to develop that own thinking skill. You cannot just be like the mindless ant when you're doing problems. You had to have your own creative thinking, and that's what's gonna make you a better math person than other person. Right? That's what you had to do. So let's figure out what if, let's say, I will probably lean on Paige's answer because I think she provide me a song thing, and Joshua also provide me a song explanation as well. And then let's see if that makes sense. So, how much a tip of the shadow is x plus y? Does that make sense? So, if I take and we're gonna call this tip, right? So, can I just say take derivative of that? Dx dt plus dy dt is equal to dt, well, d big T over t. Tip, right? And then that's equal to 5 plus dy dt was 10/3. And that's equal to 25/3 feet per second. Is equal to how fast the tip is changing. Now, let's think about this, right? How fast the tip is moving is really depends on, it's relevant to the speed of the man, as well as how fast he's growing his shadow.
Wouldn't the tip be x minus y?
What?
I mean, minus x. Like, if you the tip of the shadow, right? Wouldn't it just be the length of y?
So the tip is relevant to from the lamppost to all the way to the tip of the head of the shadow. Does that make sense to you guys? What time we got up here, by the way?
We got like 10 minutes.
Okay, so good. So those are the things that you should develop to thinking your own thing. And there's one interesting thing in this case, and it kind of doesn't make sense, but it kind of makes sense, but it doesn't make sense, is we didn't use the value of 10.
What?
That means that the question doesn't matter how many feet it is from it. It would be the same if didn't use 10.
We didn't use 10 at all.
Yeah, we should have.
Should we use 10? That's the thing. Should we use 10 or no? Because is that 10 is really relevant.
No.
No.
Hopefully not.
Because it's the length and like it's like
This
the
takes a lot, awful lot. I don't like thinking like this.
What is what? Yeah, no, it's great.
It takes too much energy.
Matter.
You could have.
Unless it's a
variable.
So it becomes a very, very interesting thinking. In this case, 10 is now, it doesn't hold any relationship to anything.
Well,
Actually,
actually,
give it to
well,
us.
actually,
DXDT.
Would it be the same for any length? No matter how far away he is.
That's our problem.
That sounds like it's not right.
I'm looking through all the steps and I don't see anything that looks immediately wrong, but I'm stuck between like where you took the derivative of 9y equals 6x, and it's like, yeah, you can't put 10.
I don't like all these
Did it tell me that?
That's the right way to do it.
If the rate at which he's moving is like 10 feet per second, 5 feet per second, wouldn't you just plug in 10 or like?
See, but it's a variable because he's moving.
Yeah.
So you can't just plug in 10 for x.
But like, I guess.
Who says?
So, okay, so this creates two different type of problem.
I just figured finding y wouldn't help.
This create two different type of problem. So this is a create. You guys gotta learn to think it throughout by yourself, and things like that. And there was another problem that in your homework I didn't assign that was a question 2. Was the light is on the floor, and the man is walking toward the light and is casting a shadow onto the wall. Okay, and then what's that relationship? That's a completely different relationship setup. And I didn't assign that question, but I do want to challenge you guys to look at number 2 as well, because number 2 has a different way the situation works. And they can be very complicated questions throughout. You got a basketball is bouncing.
I actually play basketball.
You do? I cannot tell.
I beat
Um,
TJ.
No, you didn't.
I technically did. He forfeited. I'm 1-0.
You should bring a basketball here. I can whoop your ass.
Can we actually play one day? Can we actually play one day?
Sure.
Okay, when? Like this quarter?
Bring a basketball.
I'll
The-
bring basketball.
The day
Tell me the
before
day.
Christmas break, let's do it.
Yeah, sure.
He will be wrong.
Yeah.
I'm literally the best in this team by far. Like it's not even close.
Good.
Huh?
You can literally not dunk.
I can touch rim. I can touch rim.
I can touch like it doesn't. You can't even get your hand above rim.
I can touch it.
You know, back line.
All right. So so those are the things that you are thinking when you do in today's homework. Thank you for listening. You can still go over the rest of the time on other questions and help out each other and try to think. You can more welcome to come to tutoring after school to discuss this problem today and tomorrow.
So what's the right answer? Is that the right answer?
The right answer is 10/3 is how fast the shadow is growing, and 25/3 is how fast the tip is growing.
Damn,
Because
I'm wrong with both Andrew and myself.
the
Oh my
tip
God.
the tip is including how fast the person walking and how fast the shadow is increasing at that particular time.
I tried to back Andrew, man. Did not.
All right. Thank you for recording.
Thank you for watching my TED Talk.
Alright, so that's our-
Like everyone has my full attention. I can tell them whatever I want. Like I could like you can
Yes, we did. Tomorrow, today,
Today's review day. So you have 10 minutes, right? 5 minutes? 5 minutes. Look it over question. Come on, don't close the booklet.